Hello grade 10s, it's John here. Today we're doing a really exciting topic. The topic is matter. Now you might say, well, what is matter all about? Well, we're going to show you, and you'll be in for a surprise because there are so many things that we've got to discuss, and let's have a look at those key details of where our focus is for this session. So here we go, we're dealing with matter today, and we're going to say, what is matter? Well, maybe you can answer that. What is matter? Well, let's see if you're right. Properties of matter. What are some of the properties, and how can we classify matter, the classification of matter? We're going to look at different forms that matter takes in the form of a mixture. There are different types of mixtures. Then we're going to look at pure substances, which include elements and compounds. We'll have quite a lot to say about those. And then we'll notice that all of these examples of matter come in different states. So we'll talk about the states of matter as well. Right, now that's an overview for what we're going to be looking at, but let's start with being really concrete. So what is the stuff that we call matter? Well, you might have an idea. I think that what we need to do is just have a look at a couple of examples. Well, to start off, we've got some stuff here, some yellow stuff in the plastic bag. Let's have a closer look at it. I get it out in my fingers, and you can have a really close look at it. You'll see it's all powdery stuff. All looks the same. I can crumble it, and it forms a yellow powder. Then there's this, which is quite familiar. I'm sure you've seen that around, polystyrene ball, and then we've got a candle. Now, these are all different. They all are different examples of matter. Here's some foil that you would find at home, and here's some stuff that is also a thin sheet, and it's got a grey color to it, and it's kind of a metallic look to it. And here's another bit of metal. You might have seen something like this hanging around. It's quite interesting because this is a brass ball here, and it's used to show a heating experiment, which we haven't got time to do today, but we might get time a little later. And then there's something interesting here. This stuff here has got an interesting property in that if I bring something like that together, it sticks. Take it apart, it doesn't. It pulls together. So all of these are different forms of matter. And, well, what's the general thing that they all have in common? Well, I'd like to suggest to you two big things. That all matter has mass, and all examples of matter have volume. So they occupy space. They take up space. When we say they occupy volume, they take up space. And we're going to come back to these two definitions in terms particularly of the volume when we look at the different phases or states of matter a little later. And you've seen that there's a variety of examples of stuff all around you that we would say, yes, this is matter. There are very few things that we can touch and feel and get a hold on and look at that aren't matter. But there are a couple of things that, for example, the sound that you're hearing, it's not matter. Visual things that you see, like a flame or a light burning, the light radiating, that's a form of energy. It's not matter. So there's a difference between matter and energy, and we need to understand that there is that difference. But we're going to focus not on energy today, we're going to focus on matter. So let's move on and let's say, well, what are some of the properties of matter? And all of the examples I've shown you have different properties. Well, one of the things is some of the things that I've shown you, they are strong. Of course, others are weak. So like that yellow powder, it's quite crumbly, it's quite weak, it's not very strong. Then you get some things that are called thermal conductors. We'll have more to say about that. But thermal relates to heat and what happens when you heat something. Is it going to conduct the heat or is it going to insulate? We'll talk about that a little later. Then the next that I have on the list is electrical conductors, things that conduct electricity and things that don't. And then we have things that are brittle, they break easily. Things that are malleable. Now, when we talk about malleable, we talk about something that can be rolled into a sheet. It can be bent and take a particular form. So we'd say this metal is malleable. And then the second word that is important is ductile. Ductile means that it can be drawn into a piece of wire. So if we take a closer look, I mean, you're very familiar with wire. It's thin, it can be bent. Not all substances can be made into wire, but this metal, this copper metal, is very good as an example of something that is ductile. And then we have something that is magnetic. There are a whole bunch of substances that are magnetic. I showed you an example of one. There are properties that are substances that are magnets, and there's those that have magnetic properties. They're affected by a magnetic field. Then we can say different substances have different densities. That is, they have a different relationship between their mass and volume. So remember, we said all matter has mass and volume, so that means that all matter will have different density. Pure substances have a very specific density, and that's how we can tell they're actually pure, by looking at their density. Another very important thing that we will look at is the boiling point and melting point, particularly of pure substances. These are the points, or the temperatures, at which substances change phase. They change phase from a liquid to a gas, and that's boiling point, or from a solid to a liquid. That's its the temperature at that point is called the melting point. Now, all of these are the properties of materials and of matter in particular. Materials and matter. Materials are just a form of matter that's put together for a purpose. So it's a very important word that you will see and hear. We're focusing on matter today. We're going to look now at how we can classify matter, having looked at some of the properties of matter, and we'll have a little longer look at matter in more detail. Right, now here's a sketch of being able to classify matter. The first thing to say is that we can get pure substances and we can get mixtures. I want to clarify for you what's the difference between a mixture and a pure substance. Well, here's my idea. If I had to take this candle and I had to slice through it, other than the wick, just the candle bit, what I would notice is that everywhere in the candle, in the wax part, it's the same. It's the same stuff. There wouldn't be a huge variation between one part of the candle and the other. It's of similar stuff. That we would say it's pure, doesn't have impurities. Because it's got the wick, it is actually impure. It's kind of a mixture because it's got a nylon wick or a cotton wick, and it's got a wax. So in this sense, the candle is an example of a mixture. If we took the polystyrene and we cut it in half, this is pure. All the way through, you would find polystyrene, polystyrene, polystyrene. Okay, so there's nothing much different there. But if we had to take a look at this lump over here, there are some air particles in between it. It was once sugar, but I've dehydrated it, and I'm left with a lump of carbon. And there are other impurities, some burnt sulfur and all sorts of stuff inside there that I don't want to get into. It's kind of a mixture. So the difference between mixtures and pure substance, very important that you note this. When it's the same type of stuff all the way through, then we're saying it's pure. If it's different stuff, so if we think about it, some of it might be green and some of it might be red, and then we've got a mixture. So let's have a look at different mixtures now. We're going to focus on mixtures. Well, what is a mixture? A mixture is a combination of two or more substances, okay, where these substances are not bonded, they're not joined to each other, and no chemical reaction, very important, occurs between the substances. The properties, so that's the definition, and it's something that you need to know. It's a combination of things. They've just been lumped together, but there's no joining taking place. What are the properties? They're not in any fixed ratio. That means that you could have a drop of one substance and 10 million liters of the other substance. It's a mixture. On the other hand, you could have a different mixture. We have 2 liters and 2 liters combined to make 4 liters. Well, those are all mixtures. There's no fixed ratio of the components. They don't have to go in any order. What's the next thing? Notice they keep their physical properties. So what we're saying here is that if we've got salt and iron filings mixed together, or flour and sand mixed together, the sand still stays sand and the salt still stays salt. This is the important thing. They can be separated by mechanical means. And there are a whole lot of different methods for separating mixtures, by filtering, by hand sorting, by using a magnet. So there are a whole lot of ways of separating mixtures, and none of them involve a chemical reaction. You can evaporate stuff off, you can dry stuff out, and you will be able to separate a whole lot of different mixtures. Different techniques for different types of mixtures, agreed, but they're all mechanical. They don't involve forming new substances, and that's very important. So let's have a look at some examples. I've shown you some examples, but we can give some names to them, and these are given in your textbook, in the Everything Science textbook. A liquid, so they're immiscible. We call that an emulsion. So it's an example is oil and water. When we get a solid and liquid, so like mud and water, we call it a suspension. We can have gas and liquid. So this is where you have carbon dioxide in a fizzy drink. Well, that's called an aerosol. And smoke is an example of a gas and solid, where we have the name of the mixture is called smoke, but it's actually referred to as smog. What about some examples of these are examples of heterogeneous mixtures. So what about some of the homogeneous ones? Take a look here. We've said, and we've illustrated, that a homogeneous mixture is one that is uniform, where the different components can't be seen. Have a look at this example of a mixture. I'm just going to pull it forward. Here I have a beaker of water, and here I have some colored water. They're both of the same consistency, and if I pour the one into the other, you'll notice that they mix. There is no difference between them. They're a homogeneous solution. There's no separation here. If I take a bit of water, another beaker of water, and I take some solid stuff here, which is actually a salt, and I add the salt to the water, at the moment I've got a solid inside the solution. But if I stir it, what you'll notice is that the solid dissolves until all the particles that were solid have changed, and you can't see any more particles. Right, now that we've looked at the properties of mixtures and we've been able to separate them, distinguish between them, let's have a look at pure substances. Go back to our classification diagram, look something like that. We've got mixtures on the one side, the heterogeneous and the homogeneous. Now we're going to say, what about pure substance? Recognizing that these ones aren't pure substances, what categories can we get here? Well, the first category, which is very important, is that we can get compounds. Now, compounds we'll have more to say about in a little while, but the one that I want to deal with as well is elements. So there are two forms, elements and compounds. Elements are your basic building blocks. If we have a little bit more of an insight into elements, let's get the picture of what elements are all about. If we break them apart into subcategories, well, over here you will get something called a non-metal, and over here you get something called a metal. Now the metals themselves can be broken up and divided into two further groups. So let's have a look at those, and then you'll see the whole picture. You get those that are magnetic, and you get those that are non-magnetic. And there's the classification as a big picture. Let's have an individual look at each of these components now. And we'll start off with the elements and have a careful look at what makes up the elements and what they really consist of. So what is an element? An element is a substance that cannot be broken down into other substances through chemical means. So this isn't a mixture. We're taking a substance, we're saying, let's try and get it as simple as possible. Purify it, break it apart, pull it apart, try and get the simplest form of it. We can't get it simpler than that. So elements become the basic building blocks for all of matter. They're the simplest substances that exist. And in fact, chemists over the years have started to classify them and put them into groups, as I've mentioned. They've classified them. There's the periodic table, which we'll learn more about. It's the periodic table of the elements. There are 92 or so naturally occurring elements. And more recently, we've been able to manufacture some elements of our own. We'll have more to say about that later. What else can we say about elements? Well, let's rather say something about compounds. Compounds, difference between elements and compounds is that if we take an element and we join it together, combined elements, in a fixed ratio, then we will get a substance that we call a compound. So I hope you've got that. Elements are the simple building blocks. When we join them together, well, then they form compounds. Very easy, but we need to get our vocabulary right. We need to make sure that we understand the difference between these substances. They're both pure substances and they're both combined. The interesting thing here when we make compounds is that a compound doesn't have the properties of the elements from which it comes. So for example, if we take this as a simple example and we say, we know that here is an example of a compound. If we take some sodium, which is a metal. We know that that's a metal. And we take something like chlorine, which is a non-metal and it's a gas. It's a non-metal. We'll explain why it's a metal and a non-metal just now. We put those together, we can make a compound called sodium chloride. Now, this is something that's quite common. It's known as table salt. Now, this metal, sodium, is a grey metal. It reacts with water. It's quite explosive. It forms a very dangerous stuff called caustic soda, which can even eat away bones. Chlorine is used as a poison. It was used in the First World War as a gas to poison people. It's a very horrible, dangerous gas. Put them together, and you get stuff that you can eat. In fact, that we can't do without. So, hope you can see. Forms a new substance, totally different properties, and it's combined in a particular way, in a fixed ratio, 1 sodium for every chlorine atom. And we've put them together in that way. Now, I've mentioned a word there, atom, but we'll have more to say about that in a later session. So they're formed in a very special way. Now let's have a look at some questions. Our first example is for us to be able to distinguish between different substances. Look at the table below. In the first column, A, is a list of substances. In the second is a description of the group of these substances that these substances belongs to. Match up the substance in column A with the description in B. So here we go. The first thing that we're going to say is we've got, in column A, we've got the word iron. Now, what is it? If we look at it, we would be able to recognize that iron is an element. So it's on the periodic table. It's a simple substance. You can't make it any simpler. It is an element. Now, what about this strange thing here? Now, chemists are really strange because they go from three ways of referring to things. They look at the big picture, like looking at this stuff. They can represent what's happening at a tiny level by drawing diagrams. We call that the sub-microscopic view. And then they can do a symbol, and they can write a symbol. You're going to need to learn to write and to name these symbols. So let's have a look and break down what the symbol really means. Well, hopefully you can see this has got an H, and it says there are two of them, and an S. Now H stands for the element hydrogen, so H stands for hydrogen, and S stands for sulfur. So the combination of hydrogen and sulfur is known as hydrogen sulfide. Now, this is not an element. It's a compound containing two elements. We can see the hydrogen and the sulfide. So we're going to say for iron, the answer is D. For H2S, the answer is A. Well, now, what about a sugar solution? Now, can we see a difference when we mix sugar and water? If the sugar is all dissolved, can we see a difference? No. Then it must be a homogeneous mixture. It's homogeneous. It was originally two different states, solid and liquid, but it's dissolved. We can see a difference in them. We can't see a difference. Right, what about the next one? So we're going to say that one's E. Sand and stones. Well, we can see a difference between the sand and the stones. The sand is little particles. The stones are big particles. You can see where the one ends and the one begins. So that's a heterogeneous mixture. It's number B. And that means that we're left with steel. Now, what is steel? Steel is a combination of different metals. It's mainly iron, but there is all sorts of other additives put into steel to strengthen it and to do various things. We call steel an alloy. So a metal alloy is what steel is. It's an example of that. Here I had an example of brass. And if I just show it over there, get a nice close-up of it, you'll see that it looks like it's pure substances. But in fact, this is made up of two metals. It's made up of copper and tin. And it gives it its special properties, which give this the name of brass. So when you're looking at brass screws or you're looking at brass ornaments around the house, you'll be able to recognize that this is an alloy. It's an example of a mixture, a metal mixture called an alloy. Okay. Right, now that we've looked at that example, let's go to a break. And after the break, I'll come back and we'll have a look at how we name compounds. So get ready for that. We'll be back with you in a few minutes.